A few more notes on C-strings. Currently I have the C-string which is initialized to this hello. Okay, and firstly what we can notice with the character arrays is that the size is going to be fixed. We do have more dynamic containers in C++ which we'll learn about more in upcoming lessons. But one issue that you'll have with C-strings is that you always need to make sure that you have enough characters available for whatever that C-string has to store. So those are things that you have to keep in mind. Also, you can modify the final character in the array. Remember the C-string is now a character array. Control-K, Control-I, and I can see this is a character array with a size of 7, meaning it can store 7 elements. Of course, again with an array we start at 0. So if we change the final element to something else instead of having that be null, then this is no longer a valid C-string. And if I build and run, you can think what's going to happen for a second. We're going to get garbage printed out again. As you can see, that's because the loop that is going to iterate on the array is going to continue iterating until it reaches the null character. So it will print out garbage until it reaches some null character. So do be careful with C-strings. Always ensure that the final element is the null character. Also, if you have no initialization, so we do not provide the list initialization, and maybe we specify some size such as 5. And if I build and run now, of course you can guess that we are going to get garbage once more. So with that, it is best to use the empty list initialization instead, and you'll get a bunch of nulls in that. And if we build and run now, we do not get anything printed out because the first element is going to be a null. In the next subsection, we'll come across deprecated functions. Now the use of deprecated functions is discouraged. Some more detail on what a deprecated function is. Some functions are kept for backwards compatibility, but they are obsolete and may not be safe. So we mark those older obsolete functions as deprecated to warn against its future use. And this allows the function to be phased out with time. In other words, the usage of that function will gradually stop. This is one issue with C++ and other programming languages as well, where the standard libraries have to be backwards compatible with older code. Of course, not all of the programs out there are small. Some of them are hundreds of thousands of lines of code, if not millions of lines of code. To update those will take time, and it's not always possible because of financial constraints. And with that, backwards compatibility is kind of a feature of C++, and that has its benefits, but also there are some downsides to that, of course, because you have to test to make sure that the functions that you're using are not deprecated. This is not just for the standard C++ programs, but also for programming, let's say, an Unreal Engine or Qt using the Qt libraries and so on. So you always have to check and make sure that you don't get some deprecated warning. Sometimes those will show up as warnings, sometimes they'll show up as errors. For the most part, we'll have some workarounds so we can eliminate those warnings or errors. And you may also have some sort of a time frame where you know that, okay, by the time some standard releases, I have to be up to date with my code, so I have to go in and make sure that I use the non-deprecated functions. If you develop in Unreal Engine, for example, they'll say you, okay, let's say 4.27 or something like that. Then you know, okay, I have to go and update those functions before that version releases. And of course, typically there'll be some replacement, some modern function to use instead. So again, a deprecated function is an old obsolete function, and the use of it is discouraged. So you should not be using it, use its replacement instead. In this example, I have a couple of C strings. I have this name and surname. Now, of course, you can go and enter your own name or whatever you want, but I went with Bruce Lee here because there is Bruce Lee and then there are the rest of us mortals. So we have Bruce here for the name, and of course you have surname, so I have Lee here. And now what we want to do is we want to add both of those in this full name C string. If you try and do something like this, for example, then we'll get an expression must be a modifiable L value. We've already discussed this with arrays, that the array identifier is basically a constant pointer, so we cannot assign some other pointer to that. Now, of course, you can always go and do this in a loop, so you can take the full name. We have, let's say the size for that is 20, then you can loop through and add the name, and maybe add a space and so on in there. But there is a library of functions that we can use for this instead. That is in the C string or the string.h. In modern C++, you want to use the modern file, so we are going to use C string instead of string.h. And what do we want to do? Well, we can start off by copying the name within the full name, and then maybe add a space, and then maybe go and add the surname afterwards. So of course, firstly, what we need is the full name. We need to ensure that the character string has enough space within it. It needs to store enough members so they can add both the name and the surname within that. Then we can do str copy, so string copy. With the IntelliSense helper, we can see the prototype, the destination, and then the source. It's going to take in pointer to a char for the destination and pointer to char const for the source. So we want to copy to what? We will want to copy to the full name. And we want to copy from the name. Okay, with this, typically you don't need to add a comment because this is self-documenting, especially if you look at the helper. Control so spacebar again, you can see this will be obvious what's going on. But I'm just writing this here for clarity. So we are copying the name into the full name. Now we want to add a space, and for that we can add something else. We can do the string concatenate. Once again, we have the destination, so we have full name. So we have this string.roll, and all I have in there is a space. So we are doing a concatenation. We are basically adding a space at the end of full name. What we want at the end is also a character string to add the full name, and we can do the printout of the name, whatever we want, so we can build and run that, and we actually get an error here. You might be thinking, what does this CRT stand for? Well, that is the C runtime library, which is the part of the C++ standard library that incorporates the ISO C standard library. So basically the C runtime library is the part of the older C language that we use as part of our C++ programs. Okay, so there are a few ways of fixing this particular issue. You can use this string concatenate _s instead, but before we get to that, let me just show you the other ways of doing this. Firstly, I'll go to the project settings. To that particular project settings, of course, you can right click on the project and go to properties as well. Then under C++, under preprocessor, we want to add a different preprocessor definition here. Click on edit. We need to go and copy that particular, there's a particular macro right here. Copy that. Then we go and edit to this right here, and I can just add it. Click OK, click apply, click OK. And if I build a run now, this will work fine. And I'll actually use the full name now because that's what we want to see. Build a run, and that's what we get. That works fine now. You always have to remember that we can use the new function, the safe version of the function, but that may not necessarily be compatible with other compilers. So in that case, you may want to go and fix things in this way, but I'll go and remove that now again on the project settings. Go and edit that, and I'll remove that once more. And I'll remove that, click OK, click apply, click OK, and now I'll get those errors again. Now what we can also do is before the header files, before the includes here, we can go and define that particular thing. I'll just go and copy that again. Let me build and run again, and that should work fine now. So before the lines that include the header files, we go and include this define. And so that is then defined within the specific source file only. We can also try and use no deprecate, because those are basically deprecated functions. And if I build and run, let's see if this works. This actually works too. Secure, no deprecate, that also works. This is kind of a hack. This is not what you want to do. You want to use these safe functions. And the reason why I'm showing you this is, if you look at the documentation for these functions, you may not always see those. You may see this str copy and so on, but not what we get in the error building in. You may not see these versions. String copy _s, for example. Build run, and those will now work fine. So these are some of the issues that we have to deal with when we are using older code. Some functions from the older C programming language are deprecated because they are insecure, and so we have to use a secure variant of those functions. So it's not recommended to use those functions. The more secure variant is going to catch the errors when they occur. So basically they'll be doing additional checks for errors. We'll talk about error handling in more detail in an upcoming lesson. We have not discussed error handling yet, but just as a quick example and what we mean here with a safe function, I'll go and copy this line here, for example. We'll do the older string copy. We'll copy the name into the full name. Actually comment that one out as well. And to get started off with, we'll use the unsafe string copy, the older one. I'll go and define that macro again, and now I'll go and change this full name to something like 3. So what do you think is going to happen if I build? Well, let's see. If I build and run this, we'll actually get a crash here. We get a runtime check failure, stack around the variable full name was corrupted. This is a debug error. The important thing to notice here is this is not an assertion, so it's not some check, this is an error, and I'll abort. So that version is not safe. The safe version is going to do error checking for us. Now that is not going to fix our mistake that we have here. With C strings, we still need to ensure that the string can actually store that amount of characters. Okay, we need to ensure that the size is correct, but these more secure functions can detect your errors, and then basically what they do is they handle your errors. So what does that mean? Well, we'll get an assertion failed. If I Control F5 to build and run, we will get this debug assertion failed, and it will actually tell you here the buffer is too small. An assertion is basically a predicate, so something that returns true or false, that you expect to hold true at a particular point in your program. If the condition does not hold true, the assertion fails. The execution of the program is interrupted at that point, and that is when we get that dialog box. We can ignore the assertion and continue running the program, but we can also abort to halt the execution of the program, and you can also retry. This is for debugging purposes. So again, basically an assertion is a statement somewhere in our program, some predicate that is used to test assumptions made by the programmer to assure the safety of the program. And you'll see we actually don't get Bruce printed out, it's simply going to exit here. Basically what it boils down to again is this is safer, it does error handling for us. Uncomment that. Remember I mentioned the prototype for the string copy. We have a pointer to char for the destination and a pointer to char constant for the source. Now the prototype for the string copy _s is going to be different. Control Shift Spacebar, and you will see this is templated, it takes in a size. And for this prototype we have a reference to an array, we pass in size. That is for the destination, and then we'll also have the pointer to the char const for the source. And we have a different prototype which also takes in the size in bytes. Okay, so the point is you have two different ones here, and it's going to take in the size. And with that size, of course, it can do the error handling check for us. Okay, so that is basically all I wanted to demonstrate with this. We can now move on to some more examples. A quick reminder, you can always check the documentation. So in this case, I have the documentation on the library header C-string. As I mentioned, originally this was in the string.h file, but in modern C++ we use the C-string, so we're not concerned with the header files. We use the file without the extension. And you can see this header is for C-style null terminated byte strings. We have some functions here such as string copy. We also have a string copy which is going to copy a certain amount of characters from one string to another. So you can specify the number of characters. That is what the n is for. Then we also have the string concatenate here, which is going to concatenate two strings, so string cat, strcat. Similarly, you can concatenate a certain amount of characters of two strings with that n. That is what the n is for. Documentation on the string copy, this is going to tell you what it does. Copies the character string pointed to by src, that is the source, including the null terminator, to the character array whose first element is pointed to by the destination here. With an example. They are using smart pointers in these examples. We've covered the smart pointers before. You can see in this example we have a unique pointer, so you should be able to follow along with these examples. And then also the string concatenate. If you're unfamiliar with the term concatenate, that basically means append. So we append a copy of the character string pointed to by the source to the end of the character string pointed to by the destination. Okay, so to the end of that character string pointed to by the destination. We can see in the next sentence, basically this means that the first element within the source character string, that first element is going to replace the null terminator at the end of the destination character string. Then the resulting C string will be null terminated to form a proper C string, of course. And then I have the security issues that I mentioned, so the behavior is undefined if the destination array is not large enough. Also pay attention to what these functions return. So in this case, with the string concatenate, we have a return value which is going to return that destination pointer. But of course, you can quickly check the prototype using Ctrl+Shift Spacebar as I've demonstrated before. Okay, so I'll wrap up this lecture with a quick exercise. We'll continue this discussion on C strings in the next lecture, but I just want you to take a bit of a break and go and experiment with this in Visual Studio. I've covered quite a few things in this lecture, and we also had to discuss deprecated functions. So you may want to take a bit of a break from these lectures and go and experiment. And that brings me to this exercise. Go ahead and look at the documentation and find a function that can help us determine the size of a C string. So in other words, how many characters it has. And as a bonus, there are actually two ways. So you can use a function and then also an operator that we've discussed before. The function that you'll be using, again referencing the documentation that I just talked about, that will give us the amount of characters within the string, excluding the null terminator. Then there's a different method. Don't worry about it if you can't get this other method. You might have to think about this for a bit, but it's actually easy. I'll show you in the next lecture. That is using an operator that we've discussed before, and that will give us the number of elements within the array, including the null terminating character. So go ahead and try that now, and when we come back in the next lecture, we'll continue talking about some of these functions that operate on or manipulate the C strings.